Hello everyone, today I will share with you our AVC equipment active voltage conditional. Okay, let's see our HMI interface. This is our HMI interface. Okay, and this red one is our stop button, and this is emergency stop button. This green one is rolling button. Okay.
Okay, let me open the door. And we can see the first one is bypass switch. And the second one is our slave device. Okay, the next one is master device. Okay, now we can see the first one is our manual bypass switch, and the second is our master power switch. The third is our main load switch, and the last is our main power switch. Okay, this is the back of the cabinet, and let's see, these two are fines, and we can see this part of wiring have been completed, so we don't need to modify it. And we only need to focus on the terminals. Let's see, the terminal of left is input and the terminal of right is output. Okay, and this one is current transformer, and the next transformer is connected to our electric meter, and this one is our slave device switch. Okay, now I will introduce our HMI for you, and we can see this is the program version of our HMI, and this is master interface, slave interface, auto start control interface, detail interface, and alarm interface button. In our main interface, on the left we can see this is grid voltage and grid current. On the right is load voltage and the load current. Also we can see there have grid reactive power and grid active power, grid THD, and frequency. Of course, this is load total power, load total reactive power, and load THD. And this is our master device, and the right is our slave device. When we click wrong, the master device and the slave device will running. When we click stop, all of them will stop. Also, there display the DC relay and the alarm states. Okay, now let's see the master interface. This interface also has 3 switches for reset, run, and stop. And our master device mainly used to supply power to slave device, but also it has a function for composite harmonic and composite reactive power and improve 3 phases imbalance. Now this is the order for harmonic, and when we modify MAG to 100, it represents composite harmonic, and this is KQ. When we set it to 90%, it represents to composite reactive power. Okay, now let's see the slave interface. Our slave device is used to adjust output voltage. Now we can see we set an off-grid voltage target to 220 volts. And this device is 3-phase 4-wire, so we set the wire to 4. Also, we have a low voltage thresh and high voltage thresh. When the voltage lower than this value or higher than the second value, the slave device will adjust the voltage to just we set 220 volts. Okay, next, this is unbalanced thresh. When the three-phase voltage are unbalanced and exceed 10, this device will adjust the voltage for three phases. Okay, then let's see, this is a display of output voltage and output current. Next, let's see the auto start control interface. And we can see this is a auto start enable button and it's off. But how we use this function? We can see this is start upper thresh and start lower thresh. When the voltage is higher than the first value or lower than the second value and continue for 30 seconds, the device will auto start running to adjust the voltage. Okay, on the right, we can see this is stop upper thresh and stop lower thresh. After slave device running, if the load voltage between the upper thresh and the lower thresh value, the slave device don't need to adjust the voltage. Continue for 30 seconds. The slave device will stop. Okay, let's see the next page. In detailed interface, we can see the grid current, load current, grid PF and load PF, load THD, grid THD, temperature, voltage THD, and load reactive power, grid reactive power, grid power. Also, we can see our device output power, output reactive power, load power, and load reactive power. Okay, this page is for the master device, and let's see the next page. This page is for the slave device. In the left bottom, we can see this is DSP. Wait a moment, the 48 is the temperature of DSP, and 14107 is the version of DSP. Okay, let's go back. In alarm interface, when our AVC device have error, it will display and it's convenient for our to find problem. Okay, now I will demonstrate the function of our master device. Just as I said, our master device has a function of composite reactive power, harmonic, and three phases unbalance, and we can check the data on the power quality analyzer. This is our power quality analyzer, and it's connected to the grid side. Okay, this is our another analyzer, and it's connected to the load side. Now we can see the data. The THD is about 55%, and it mainly has 3rd, 5th, and 7th harmonic. And also we can see it has some reactive power, and the PF only about 0.4. Also we can see the three phases current is unbalanced. Okay, let's see the next one. This power quality analyzer is connected to the grid side, but the AVC device is stopped, so the data on this meter is as same as load side data. Okay, we can see. Okay, let's see the current interface. The current is unbalanced. and it has some harmonic about third, fifth, and seventh. Okay. Now we run our master device. Wait a moment. When it outputs stable, now we can see after our master device composite, the THD is reduced to about 30%. Also, we can see the current of 3 phase is balanced. And we can see the power factor is about 0.999. It has a good effect. Okay, next I will demonstrate our slave device function. Just as I said, our slave function is used to adjust output voltage. First, let's see the data. Okay, this is our analyzer, and let's see the load voltage. It's about 230 volts. Now I will modify our grid voltage target to 240 volts. Okay. Now we click the run. Wait a moment. And now we can see the output voltage is about 240 volts. Okay, let's see our analyzer. The load current we can see is about 240 volts. And this is grid voltage. It's about 230 volts. Okay, that's all. Thank you.